Now, without any further ado, let us move on to our session on healthy safe spaces, edge to cloud solution with Azure Sphere and IoT Central. And today we have Dave Glover as our speaker. A very good evening to you, Dave. And to talk a little bit of Dave Glover, he's a regional cloud developer advocate at Microsoft, who is an expert in IoT security, and also he has done and is doing a lot of tech talks on IoT development. So he's also situated in Greater Sydney area. So Dave, the virtual screen is all yours.
Okay, thank you so much for the introduction and welcome everybody to Dev Days. I think it's probably the first day, so hopefully you'll have a great week of sessions. What I'm going to do now is just share up my screen and bring up my slides. Okay, so fingers crossed, you can see my slides and let's move that around a bit. Alrighty, so this session here is called Healthy Spaces with IoT Central and Azure Sphere. Now, this session and this project was actually inspired by the pandemic, unfortunately, and it was really around the move from people working in the office spaces to working at home, and working at home often in an environment which didn't have such great ventilation. And it was just kind of trying to track that and trying to create a more healthy environment for people to work in. The other thing is this project is also fully documented and is available, that link here. So the github.com Azure Spaces. And if I just bring up my browser over here, so this is the project up on GitHub in the Azure Sphere gallery. And fear not if you kind of really interested to go and reproduce this. All the documentation for how this project works is sitting up on the internet, and it's at this link down here. Okay. The other thing is, do feel free to ask any questions. So I think if you put the questions in the chat window, I would do my utmost to keep an eye on the questions, and I will try and answer them as they come up. But if I fail to spot them, if I don't see them, I will answer them at the end of the session, so fear not. So the agenda for this session is kind of covers off in roughly 3 areas. So we're going to look at CO2 and healthy workspaces and kind of what that means. We're going to look at the overall solution architecture for this solution. And then we're going to look at the developer experience. And in between all this, I'm going to be doing some demonstrations so you kind of get to see how everything works. So both around IoT Central and then from a developer experience as well. So fingers crossed, if you're a developer, you'll be able to follow on easily enough. And if you're not a developer, do stick with it. I've tried to keep it reasonably simple so you can kind of understand what is going on with the project. Oops. Alrighty, so the first thing to appreciate, and this is kind of from various websites around the world, which is looking at what are healthy levels of CO2 and what is the impact on us. And the original idea of the project was, are CO2 levels making you happy or sad or grumpy? I think was kind of the idea behind it. And to understand what are kind of reasonable or healthy CO2 levels in our environment, the outdoors, kind of the general outdoors, the level of CO2 measured in something called parts per million is around about 350 to 400 parts per million. By the time you move inside, and we've got a reasonable degree of ventilation, then the parts per million at what we call acceptable levels is around about kind of 400 to 450. If the CO2 levels kind of start creeping up to around about 700 parts per million, which is actually pretty easy after you've got the doors closed, then that's when you start getting headaches, you start aching and things like that. If you start getting up to about 1,000 parts per million, then you start getting a bit drowsy. And if you get up to around about 2,500 parts per million, then that can really not very good for your health. So if you're working from home and you're thinking, oh, why am I always getting tired at this time of day, or I've got headaches, then maybe just one of the reasons is the ventilation in the area that you're working in. And maybe one of the things you can do is maybe just open up the window and let some, hopefully some fresh air into your working area. So that was the kind of premise behind this project. And this was to give you some ideas of when I started measuring it. Started measuring the CO2 levels in my work area. And I had the windows closed and the doors closed, and just basically keep out the noise of the rest of the family. And you can start seeing is that during this day, and this was at 4 p.m. or close to 5 p.m. in the day, the CO2 levels started getting up to around about 1,600 parts per million. And that's starting to get to quite an unhealthy level. I also do quite a lot of talking. I suspect you're also doing a lot of meetings on Zoom or on Teams or whatever you're meeting on. And by the time you're actually talking to a screen in an enclosed environment, the CO2 levels can actually start escalating quite quickly. And that's why we tend to get a bit drowsy in meetings and things like that. So this was an example here, and this was real data in my work area, just showing what can happen. And since then, I've absolutely changed my working behavior as well in terms of opening up doors and windows and things. Now, in terms of the overall architecture of what we call an IoT solution or Internet of Things solution, or what's also becoming known as kind of edge to cloud solutions as well. But fundamentally, we have things, and things tend to be devices which have sensors attached to them, and they generate data. So in this case, a thing is a CO2 sensor, which is connected up to an Azure Sphere, and that is going to be sending data to the cloud. And in this case, the data going up to the cloud is going to IoT Central, so Azure IoT Central. And what we want to be able to do behind this, we want to be able to generate insights based on that data, kind of understand what is going on. And then ultimately what we want to be able to do is generate actions. I maybe send an automatic alert to say, hey, did you know that the CO2 levels are too high in your workspace? Or maybe even better, you might want to go and automatically turn on a ventilation unit and start ventilating the air inside that workspace. That would be kind of the ideal scenario. So fundamentally, an IoT solution is about things, insights, and actions. And in terms of this solution, what we've got things, and in this case here, we're running what's called Azure Sphere, and I've got an Azure Sphere device. And then on that Azure Sphere, we've got a CO2 sensor, and that CO2 sensor is sending, on that Azure Sphere, is sending data to the right-hand side of this image, which is Azure IoT Central, which is an IoT web portal where you can go and design reports and things like that. And it's up in IoT Central, we can get insights and initiate actions into the data that we're getting from the devices. Now, I'm going to talk a bit more about these components in much more detail as we go along. Okay, so the first thing I want to talk about is something called Azure IoT Central. And it's essentially a fully managed service. You go in there and you go and define what we call views. You can go and set up rules. You can go which trigger actions. It's extensible. You can store data into Azure Storage, or you can go and hook it up into Dynamics or webhooks or things like that. And it's great for visualizing data. I think of it as a really quick way of being able to realize the value of IoT in your organization, or even your home or your communities, or government too, for that matter. So I'm going to give you a bit of a demonstration of what you can do with IoT Central, and you can see kind of how it works. So the first thing I'm going to do is I'm going to bring up, okay, so this is IoT Central. So as I said, it's a dashboard, and you can go and define what we call views. And I can go and look at the devices. So you can see in this case here, I've got 2 devices set up, and these are hooked up under Azure Sphere CO2 monitor. Now I'm using Azure Sphere with a solution and IoT Central. Keep in mind, you don't have to use Azure Sphere with this. I'm using it because it's a great end-to-end secure solution, but it could be other device platforms as well. I can go into this device here, and you can see I've got various views. So I've got an about view, I've got an overview view, and you can see in here I can go and let's say I'm not interested in the air pressure. There's not too much I can do about the air pressure, so let's say I'm not that interested in varying that. Or I can turn off the humidity. I can expand these views and things like that. I can go and look at different views of the data that's coming through. So it's really quite a flexible environment. So this is what we call live telemetry that is streaming in from this Azure Sphere. So I literally have this Azure Sphere in the room next to me, and the current carbon dioxide levels, parts per million, are exactly 555. And you can see the humidity in the room is 51%. And the air pressure here is around about 103 millibars. And the temperature is actually closer to 25 degrees. This is slightly overstating it. The other thing I like to do when I'm building IoT solutions, this is just tracking memory usage, just kind of like a bit of housekeeping. It's not the kind of chart that you'd give to an end user, but it's quite useful as a developer. I've got another view in here, and I can go and set alert levels. So for example, I might want to go and set an alert level. In this case, what it will say, if the parts per million go above 800 parts per million, then I set a beeper and it starts beeping away. I can set the altitude where I am, because it turns out the altitude can have a marked impact on the sensitivity of the CO2 sensor. The higher you are, obviously the less dense the atmosphere is, and then if you tell the sensor the altitude, it can compensate that for your current altitude. If I go back over to so just to be clear over here, so in this chart here we've got what we call telemetry, which is streaming in, and these boxes over here on the right hand side, they are called properties. So they're the kind of two fundamentals, or part of three fundamentals. You've got telemetry, which is streaming. You've got IoT central properties, which are kind of like a point in time telemetry. So as you can see down here, it says now. So basically the last time this reported, this is the point in time, and it says the point in time is now 551 parts per million. If I go and look at about, the about is really just showing the properties. So I've got a number of properties. As I mentioned before, properties are about point in time. So you can see the current CO2 alert level is 1,000 parts per million. I'm at 51 meters above sea level. The current parts per million is 553, temperature, etc. So those are just various properties from this device. I've also got commands. In this case here, I could go and run a command to go and reset the device. I'm not going to do that in the middle of my demo. Now I can also go and do things like manage templates. So the whole thing is template driven, and we kind of got the idea of views. So we've got views here, and I've got an overview. And this is where you go and really go and describe what a view will look like. So what elements make up that view? And then you can go in there and you can go and change settings and things like that. So the whole idea behind it, it's really customizable to the whole thing about IoT Central. It's customized to what you want to go and build. And you don't have to, it's really no code or very low code, mostly no code. It's just a matter of going to finding these forms. As you can see that is the form there for overview. That is the form there for my about view, etc. I've also got things like analytics. So I can go and create a query. I can go select a group. In this case, I go and select CO2 monitor. I'm interested in carbon dioxide parts per million, and I'm kind of interested in pivoting on that data by device name. And the device name might be the location in the office or might be the location in the home and things like that. We're going to analyze this, and you can see that now I can go and dig into this data. This is actually time series analytics behind all this. And you might say, well, that's kind of really interesting. What was going on? And you can see I can go and select a particular device. So let's say I'm really kind of more interested in this one, which is called Seed Studio. And what you can do is you can drag and you can zoom in. And the idea is, this doesn't 100% make sense for this example, but the idea is you can start drilling down into that data and thinking what was going on at this particular point in time, and you can start finding some correlations. So I could add in other fields into this. Maybe I might want to go and add in temperature. And we can go and analyze this, and you can see now we've got temperature as part of the analysis for the data. And again, this could be a whole range of solutions. I'm showing here one about CO2, but this could be monitoring a factory or a building or a city or whatever it might be. And you've got the ability to start drilling down into the data and understanding the relationships between the data. So that's kind of the idea behind analytics. So you can do some really quite smart stuff with it. We've got rules. And I can go set a rule. So for example, I can select a rule here and I can say, I might go and set up a, based on telemetry, looking at parts per million. And I want to say if it is greater than, if I get greater than 1,000 parts per million, I want to go and send an email and send to admin, whatever it might be. Or I might want to go and kick off a workflow. So I will just drop that down. Maybe I might want to go and kick off a workflow, and I might want to kick off something into maybe an Azure function, for example, using a webhook. So really extensively, you can go and set up these rules and say, that's interesting. When I get to a certain threshold, I would like to initiate an action. It might just be notify somebody that, hey, look, the CO2 levels, go and open the window. Or it might be more automated. Perhaps go and turn on the fan, which is connected to the internet as well. So hopefully that kind of gives you a bit of an idea of what you can do with IoT Central. It's very much about templates, and you go and define these templates, and then you can go and build your application. And as I said before, what I love about IoT Central, it's a really quick way to realize the value of IoT devices and your IoT solutions. So you're building out your devices, your sensors, your kind of ideas, and then maybe you want to take it along to some part of your business to say, hey, look, this is what we can do for the business, or this is what we can do for home, or whatever it might be. That's the general idea behind this. Okay, so back to the slides. Okay, so the solution that I'm using, I'm actually using, and I've got on my desktop here, I've got an Azure Sphere. So this is the device up on the left-hand side. And I'm using what are called click, they're called click sensors, or they're called clicks. And the idea behind these clicks is that you put them onto these click sockets. So you can see on this developer board over here, if you can see my mouse, you plug those in here. And so I've got one which is a buzzer. So basically what happens when the CO2 levels get above a certain level, above a threshold that I'm going to define in IoT Central, it will start beeping, and it's got an annoying, irritating enough beep to say, hey, look, I should go and open the window. And on the far hand right side over here, we've got what's called an HVAC click. It's a microelectronica CO2 sensor, which again, I've got plugged into it. So that's kind of the setup I've got on the device end. And I'm going to show you a bit more about how that all works in a moment. Okay, so I mentioned before that with IoT Central, you can really use any type of IoT device. But this talk is specifically about Azure Sphere on the device side. And I just wanted to talk about why Azure Sphere and why you should think about it. So if you do any work around IoT today, then you'll probably appreciate there are a lot of security risks behind IoT, having IoT devices, connecting them up to networks, connecting them up to backend systems. And a lot of people are very kind of rightfully kind of a bit concerned about IoT and IoT security. So Azure Sphere addresses, and it's really been designed to address these security concerns. So Azure Sphere is what we call secure by design and secure by default. And I'll get into much more about what that means in a moment. But Azure Sphere is fundamentally about creating a secure by default IoT platform that you can go and build IoT solutions on with confidence that they're not going to get hacked. And that's really what the fundamental idea behind this. And to kind of give you one of these stories, and it's a great story about what can happen if you're not careful around IoT devices and IoT security if you don't think about these. So in this case here, we've got a fish tank that was actually sitting in a casino in the US. And what they decided to do was that they wanted to be able to automate this fish tank. They wanted to be able to automate feeding of the fish, and they wanted to be able to automate the temperature. So of course, what do you go and do? You go and put an IoT sensor into that device. And of course, they wanted to connect it up to the internet. What they actually did is they connected it up via their work network, which was probably not a good idea to start with. And then what happened is that people came into the casino and they managed to hack in to the IoT sensor that was sitting inside this fish tank. And then from that fish tank, they were able to hack their way onto the corporate network. And then from when they got onto the corporate network, they were then able to steal data out of various corporate databases to the order of around about 10 gigabytes of casino data. So that kind of gives you a bit of an idea what can happen if you don't think about IoT security. And what we're trying to do with Azure Sphere, in fact, what we're doing with Azure Sphere is making these devices secure by default. So these kind of scenarios can't happen. So what Microsoft and the industry have done is we've defined what we call 7 properties for highly secure devices. And I'm not going to go into these in great depth right now. Down at the bottom of the screen, there's a link. So take a screenshot of this. The link is aka.ms/7properties. But there are some fundamental ones, like a device should have what we call a hardware root of trust, an unforgeable identity for this device. A device should have renewable certificates, renewable security. So one of the biggest points of entry for hacks is that systems are based on passwords. Often they use a password for their IoT device. And invariably, those devices become very easy to hack. So one of the things we want to make sure is we're using certificate-based authentication, and that so certificates are renewed. So we just make sure that we understand those, so to maintain that level of security. Things like error reporting are fundamental. If you don't know that you're being attacked or something's wrong with the system, then you can't mitigate against it. So those are the kinds of things. So Azure Sphere as its entirety supports these 7 properties. In fact, Azure Sphere is made up of 3 components that support those 7 properties of highly secure devices. So we have what we call Azure Sphere Certified Microcontroller. And I showed you one before, the first one that's come to market is by MediaTek, and that AVNet board that I showed you, that AVNet starter kit, has a MediaTek chip on it, and it has a hardware root of trust. The second component that delivers on these 7 properties of highly secure devices is the Azure Sphere OS. And as part of that, we maintain currency. So the biggest challenge with security, as I'm sure you appreciate, is security is an ongoing issue. So you might think, great, I've tested my device now and everything works and it's secure and I've signed it off. The problem with that, of course, is that security and security issues evolve. Hackers get smarter. Often they're driven by money and things like that, opportunities, and they get smarter in different ways to attack systems. So the main thing about this is that security is evolving. So one of the promises behind the Azure Sphere OS is that we maintain it. So we have a team of experts, security experts, and they are looking out for issues around security and what we can do to mitigate them. And then we will update the operating system. And now the Azure Sphere operating system is actually built on a hardened version of Linux, embedded Linux. So that's one of the promises around Azure Sphere. It's around maintaining an ongoing secure platform for IoT or edge to cloud solutions. And then the third part of the solution is what we call the Azure Sphere Security Service. And it's responsible for making all the parts work together. So it's a thing responsible for brokering trust, setting up certificates, detecting emerging threats. So if we realize that that's interesting, we think that there is a pattern here of people trying to hack into these Azure Sphere devices, then that data gets reported. And then we can mitigate it by updating the operating system, say, okay, we think there is a new style of attack on IoT devices. We will go and update the operating system and go and deploy that out to the millions of devices, and they will then be secure against those new styles of threats. But it's also, so the security service is also responsible for renewing device security, for app reporting, also for your app distribution, because your app may have issues with it as well. You've delivered out your version 1 application and you need to go and deliver the next version. Maybe there's bugs in there, or maybe the customer has asked for new features, and we have full support for over-the-air update for your application. So you can go and fix issues in your application, and you can go and deploy new features and things like that. So Azure Sphere Security Service is responsible for all that as well. Now, Azure Sphere Microcontroller itself, and I won't go into this in too much detail, it's what's called a crossover microcontroller, and is made up of five controllers, what we call 5 cores, 3 of which you can go and deploy custom applications. So on the, where my mouse is over here, on the bottom left-hand corner, we have the Cortex A7, and that runs this hardened version of embedded Linux, and it is responsible for running system services, so application updates, certificate renewals, running your application. When you go and build an application that runs on this Cortex A7, you're actually building a POSIX style application to a POSIX API. Now, clearly we don't have the full POSIX API running this microcontroller. We have just the parts that are relevant for kind of IoT microcontroller development. And on the bottom right-hand side, there are another 2 cores that you can go and run applications on. And these are what are called real-time cores, where you can go and run real-time applications. So these are applications which typically require highly deterministic timing. Would be a good reason why you might put an application onto a core. And these real-time cores can communicate securely with a high-level core, and that high-level core can take that information for the real-time cores and then relay that information up to the cloud. But those are the main parts I want to talk about. Okay, so the next thing I want to talk about is the overall developer experience for building applications for Azure Sphere. So there are developer tools that are available, and these are all free of charge. So, and it really just depends on what your background is, which developer tools that you'll want to use. So I'm normally developing on Windows, and most of the time, though not all the time, I'm using Visual Studio 2019. It's just what I'm used to. It doesn't mean it's the best or whatever, it's just mostly what I'm used to. And the demo I'm going to do will be inside Visual Studio 2019. And that works on Windows. And that also includes an integrated debugger, and which is just amazing to be able to step through code and understand what is going on with your application. Now, the other IDE that you can use is Visual Studio Code, and some people love it, and I really enjoy it as well. And sometimes I develop in code, sometimes I use Visual Studio. And when you're using Visual Studio Code, you can develop Azure Sphere applications using Windows and Linux. And again, there's an integrated debugger, and it's a great experience. You can step through your code, look at variables, all the kinds of things that you're used to when perhaps you're building Windows applications or iOS applications or Android applications. You can step through your code and understand what is going on. Now, there's also command line interface. You might be thinking, well, why would I want command line interface? And they can be very useful if you're trying to integrate it with an overall build process. You might have a tool chain that you're linking up into a production environment, and you just want command line, and you've been tested all the code, you want to build it, and that runs on Windows, Linux, and Docker too, for that matter. So you can go and do that on a Mac. And there is also the Azure Sphere Sdk. Now, on the right-hand side, you'll see the Azure Sphere, and this is the device that I've got on my desktop. I took a photo of this device a couple of hours ago, and you can see I'm running an Azure. This is the Azure Sphere AVNet board. See this chip in the middle? This chip here in the middle. Whoops, sorry about that. Over here on the left-hand side is the MediaTek board. So the MediaTek. Let me just close down. I thought I had closed it down, but anyway. This chip over here is the MediaTek Azure Sphere microcontroller. And I've got the click buzzer over here and the click CO2 sensor. Alrighty, so this solution is actually building and actually uses something called Azure Sphere Devx. Now, Azure Sphere Devx is a community-maintained library that simplifies the development of Azure Sphere-based applications. Now, Azure Sphere Devx is actually being built off the Azure Sphere samples. So we have a series of samples, and that's been used to go and build this Devx environment. And the advantage of Devx is very composable. So it makes it much easier to go and build the application. Now, we have the core concept behind Azure Sphere Devx are called bindings. And there are a number of types of different bindings. And then behind bindings, we have what are called binding functions. And then we have binding callbacks. And I'll explain those a bit more. You're going to see those in code, what those mean. But the core idea behind this is that Azure Sphere Devx is designed to simplify often quite complex tasks, really almost down to one line. Some of the inspiration for this was really kind of watching Python developers. And you look at a Python developer, and often it's very expressive. You can have one line, which will do quite a lot for you. And that's kind of some of the rationale behind this. Now, the developer environment for Azure Sphere is C, but if you're looking at the code, you can kind of look at it and think, I understand kind of what's fundamentally going on. So that's the goal behind Azure Sphere Devx. It should be very readable. And then as a developer, it should be pretty easy to write as well. So what I'm going to do is now demonstrate how this application was built. And while I'm here, I thought I had turned off Facebook Messenger, but anyway. So what I've got here is I've got Visual Studio. So I could do this in Visual Studio Code, but I'm doing this in Visual Studio. And I'll try and go through this not too quickly, because I know what it's like when you look at a lot of code on someone else's screen and you think, I don't really understand what's going on. So I'll try and go through here not too quickly. The main part of this application, if you've done any C development before, is typically the entry point is main.c. And in main.c, I have an include statement, which is all the declarations, and they are sitting in main.h. And if I scroll down through this application, the main entry point really for any C application is main. And of course, we're passing in the arguments and variable and the number of variables that have been passed in. And then what main does and main.c does, it does things like, the first thing it does is initializes the peripherals and handlers. In fact, it calls this C function up here called init peripherals and handlers. And then what it does is this application sits in what's called an event loop. And an event loop, basically what happens, it's going around in a circle saying, is there any work to be done? Is there any work to be done? Is there any work to be done? If there is work to be done, then that work item will be taken off the queue and then it'll be executed. And basically within the application, the way you control this application is that you effectively put a message onto the event loop to say, hey, in 1 second or 20 seconds or half an hour or 100 milliseconds, I want this application to go and do such and such. I want it to go and execute. I want it to go and read the sensor. So that's what it's doing. So the fundamental architecture behind the recommended approach for Azure Sphere applications is to use an event loop. The other advantage of event loops is that they run on the same thread. So your code is kind of thread safe. So it's a very nice model for building applications on constrained devices because it uses less resources. Now, if you really need to use threads, you can absolutely use POSIX style threads, or the pthread library. And that works beautifully, but just keep in mind that it uses more systems resources. But sometimes you need a thread. And then should the application terminate, maybe a sensor failed or whatever it might be, there's a system update or an application update, then you go and do things. Then the next thing, what will happen, it'll fall out of this event loop and it'll go and close the peripherals and handlers will be called. And up here goes the function to go and shut down the timers, close the I2C bus, and stop the event loop. So that's kind of what's going on. And then ultimately what it will do is it will return back to the operating system the exit code. So maybe this application failed because of a particular scenario. And it's very useful because you can download these reports and look at the exit code. So you can think, now, why did this application fail? And you can go back and look, that's interesting. This application failed on this exit code. Because you can see that in the downloaded error report, and you say, that's interesting. I've got an issue with memory, or I've got an issue with a sensor, or something is going on with my application. And it's a very useful way of debugging applications. Okay, so in main.h is where I put all the declarations. So in main.c, it's really just all the code. So the way I've just split it, this is just a style thing that I've taken. I like to have in main.c just my application code, and then in main.h, I just want all my declarations. It's just a style thing that I've chosen. It's nothing around Azure Sphere application development. It's just, I thought it was a tidy way, a clean way of developing applications. So this is there's just some boilerplate applications in here. I'm just including some libraries. I've got some C functions, so forward declarations, prototypes, and I've got some global variables. And the other file that I want to draw your attention to is this thing called app manifest. So if you remember, I said around Azure Sphere, so Azure Sphere is secure by design and secure by default. So by default, an Azure Sphere application cannot connect to any network resources, and it cannot connect to any hardware peripherals. So to be able to connect to those endpoints, you need to declare them. So for example, down here, if I did not, so these are actually slightly fake versions of the endpoints for my IoT solution. Excuse me, for my IoT Central solution. If I did not declare these inside my application, then the application would not be able to connect to IoT Central. Now, the rationale behind this is that kind of the issue with IoT security, where someone might hack into a device and then start using it for unintended purposes. So that case of that casino, where they were actually hacking into the sensor, then they'll manage to get through that sensor onto the corporate network, and they'll manage to get to other network endpoints, the database server in this case. With Azure Sphere, that is not possible, because what's happened is that the Azure Sphere device is locked down by default, and the Azure Sphere application can only access connections that have been declared. Now that is the same thing for peripherals. So I can only connect to what we call an ADC, so an analog to digital converter. That's a type of sensor or type of device and hardware. I can only connect to this I2C bus called I2C ISU2. I'm using pulse width. I can only connect to those. Hopefully you're getting the idea. You have to declare everything that your application wants to be able to use. And the whole rationale behind that is to mitigate against the possible scenario where someone would hack into the solution and then try and use this device for unintended purposes. And these are locked down by the operating system. You cannot change them. It's what's called sticky-based security. So the only way that you could ever override this would be to reboot the device, and then these settings would be reset again. So they're really impermeable to being hacked. So those are the three files I wanted to talk about. So what I'm going to do now is just show you quickly how I go and build my application. Now I've got some various bits and pieces I'm going to copy and paste. So you remember I mentioned around Azure Sphere Devx, and one of the key elements to it are bindings. And bindings are just C structures. They're nothing particularly fancy. They're just a way of keeping all the variables that are required for a timer, for example, to be able to push a timer into the event loop. It's just a C structure. If I come over here and go F12, you'll just see it's a C structure. So nothing overly complicated about it. I've just got a naming convention and I've called them bindings. And other people might call them a context object, very similar concept. And you can see in here, so I've got a timer, and this is the variable name for this binding. And what it's going to declare a timer that is going to fire every 6 seconds. And when it does fire, it's going to call this callback or this handler called publish telemetry handler. And then I've got another one over here called another timer binding, and it's going to be responsible for reading telemetry. So this first binding is a timer that's going to fire every 6 seconds, and its role is to publish data to IoT Central. This timer, it's responsible for reading the sensor data. Now, by the way, I've set these to be 6 seconds and 4 seconds. Most solutions, it would be nothing like as fast as this. I'm doing this because it's a demo, and otherwise, if you had to wait for 30 minutes, it would be a long time to wait for the demo to complete. So I've just sped up the demo. This read telemetry is going to call a handler called read telemetry handler. And I've also got a series of what we call I2C. So I've got 2 I2C sensors that are connected to this Azure Sphere. And there are some bindings for this. And this is going to be responsible for opening that. And then as a convenience, if I look at my I2C, I've got an array and I call them sets. And in there, I'm passing by reference the 2 I2C bindings I've created, the CO2 sensor and the onboard sensor. And I'm doing the same thing for the timers. I'm creating an array of timers. And you can see up here, this has got a reference to my timer binding up here. And this is my published timer. So hopefully that's reasonably apparent what's going on. Now, what I'm going to do is I'm going to pop over to main.c, and I'm going to post in the callback handlers. And the first one I'm going to post in, or paste in, I should say, it's the one that's responsible for reading the telemetry. So this is going to be called. So I come over to here to this one. Here's my read, and every 4 seconds, an event is going to be put onto the event loop. So remember, main.c, is there another event? Is there another event? 4 seconds goes by. Yes, there's an event to be called. So I'm going to call in 4 seconds, read telemetry handler. And this is going to be the function, the C function that's called. And there's a little bit of infrastructure that has to be done. And then the next thing I'm doing is I'm reading the onboard sensors. So this is going to read the temperature, the air pressure, and I think it was the I think it's actually just temperature and pressure. And then what I'm going to do is I'm going to read my CO2 sensor. and I'm going to pass in this object called telemetry. And then the next thing I'm doing is I'm going to validate this data. And this is one of the things that you should always think about when you're building IoT solutions, or any solution for that matter. You should validate input. In this case, I'm validating the data that's coming off my input, off my sensor, and I'm just saying, is the value that for temperature in range? Is it between -20 and 50 degrees Celsius? Is air pressure between 800 and 1200? And these are just ways in which you can just, is this data sensible? So it's just kind of a useful test for doing these things. Otherwise, it's false. And then what's going to happen when that finishes, what I'm going to do is I'm going to put on another event. In fact, I'm going to run this after 4 seconds. We'll just speed this up a bit. So what will happen here is I'm going to set what's called a one-shot timer. So basically, it's going to kick off reading the sensor again in 4 seconds. Okay, so the next thing I'm going to do is I'm going to copy in the callback handler for publishing data to IoT Central. So like all timers, there is a bit of infrastructure code. And then the next thing I do is I say, okay, I've got this other function up here, which is validating the data. So this is going to say if its value is going to be equal true if these tests all pass. And if I come down here, say, okay, well, the data is valid. And the other thing I say, am I connected to Azure? And if I'm connected to Azure, then what I'm doing is I'm serializing my data, my telemetry, into a JSON string. And then I'm going to publish that data to Azure IoT Central. So getting back to that point I made before about Python, the whole idea behind Azure Sphere Devx is that you should be able to look at this and say, okay, well, this is going to do a publish. Okay, I'm reasonably sure what this is doing. This is doing a JSON serialize. So the library supports kind of very common things that you would normally do with your application. And then the last thing I need to do is I need to go and initialize these objects. So I'm going to come down here and I'm going to paste into my init peripherals and handlers. I'm going to open up my I2C. I'm going to initialize my CO2 sensor. I'm going to initialize the onboard sensors, and I'm going to start my timers. So remember, init peripherals and handlers gets called, and the main entry point, there it goes there. And you remember, these timers are going to push messages effectively onto this timer loop or this event loop. And this event loop just runs around saying, is there a new event? Is there a new event? Is there a new event? Oh, there is a new event. Go and execute that callback. Alrighty, so what we're going to do now is I'm going to deploy this application. And while that's deploying, I'm going to check if there are any questions. And there aren't any questions, so feel free to ask any questions. Now is a good time. And hopefully that deploys. Alrighty, so that's now deploying this application onto my Azure Sphere. And I'm going to look at the device output. And the device output is a window into what's going on the Azure Sphere. And we can see there is a serial, so it's saying it's found a sensor. So look down in this area that I've just highlighted. And in a moment, it will say it's connected up to IoT Hub or IoT Central. And then what I'm hoping it will do, it will send out, it will show me this is the serialized version of the telemetry, the JSON serialized version of the telemetry that this device is now sending to IoT Hub. Now, if I come across to IoT Hub and I'll just bring this up here, I'm going to switch to a different device. So I'm going to switch to this device here, and I'm going to look at the raw data. And we're looking at this data here. So this was message 3. So if I just turn this into a window, you can see that I've got message number. We'll just come back over here. You'll be able to see that the last message that was sent was message 5. And if I look down here, that was pretty close to where message 5 was sent. So that's how you can send data. So you can see it's a pretty straightforward. These bindings make it very easy for you to really declare what you want to go and do. So you go and declare your timers, and then you go and initialize, you create these binding sets, and then in main.c, you're going to initialize these sets. I've got my timer set here, so it's going to initialize these timers and things like that. Now, I appreciate I went through this reasonably quickly, so this is all documented in that original GitHub page I showed you. Right, I'm going to stop this. I'm just going to take this application one stage further. So I'm going to pop back to my bindings, and I'm just going to bring up my page to copy and paste from. And I'm going to paste in some more bindings. And we'll paste them in here. And I've got what are called device twin bindings, and device twins map to properties in IoT Central. And in here, I've got a property called alert level, and it is of type int. And when I receive a property update from IoT Central, I'm going to call this handler called set CO2 level. And then I need to initialize that. So I'm going to go across to main.c. In my initialize, just scroll down here. I'm sorry to jump around the screen a bit. I'm going to paste that here. And what I'm doing is I'm subscribing to property updates that are coming from IoT Central. So what I'm going to be able to do is I'm going to be able to set an alert level from IoT Central. And I'm going to paste in the callback. And we'll come down here and I'm pasted. So this is going to be called when I update my IoT Central property settings. So I'm going to deploy the application. And while that's deploying, I'm going to go back to IoT Central. And we're going to look this up. Now, even though it says disconnected, it just takes a moment for the status to change. So we've got some initial data. You can see that start to flow through because I had the device turned off before. And I've got the settings page. Now, at the moment, the settings are set. So the CO2 alert level is going to be set to 1000. Now, a property is what is stored inside IoT Central. And that property is, the information is populated down to the device using something called a device twin. And a device twin is a JSON document, which basically is a representation of the data that will be held on the device. Okay, so if I come over here, you'll see that my application stopped at the set CO2 alert. Now, if I hover over this, so just mark this, so this is the value that's been sent to me. If I hover over this, you'll be able to see that the value over here is 1000. And if I come and look over IoT Central, surprise, surprise, it has 1000 in it. So if I step through this code, I'm just going to go and press F10 to step through the code. And you'll see that first thing, like all solutions, I'm validating the data. I'm just saying, is the alert level between 0 and 20,000? Seem like a reasonable range. And I'll just say if the telemetry is valid, and then we'll update that. And you'll see, whoops, we'll just run that through again. Okay, slightly confusing myself. I'm going to come back over here, and what I'm going to do is I'm going to set the CO2 level to be 400 parts per million. So I've saved that, and you'll see that the breakpoint has got hit on the debugger, on the code that's running on the Azure Sphere, and I can step through my code, and at this time it's going to say, you'll see down here, it piped up a message called CO2, and I look down here in my display output, you can see the CO2 level is greater than the alert level, and I'm just going to run that. Now, what happens with this application? Normally, I've got a buzzer, so I wouldn't normally just post a message because that's obviously not very useful. I would normally start the speaker or the buzzer beeping, so you know that there is a message going on, that there's an event. So that's the kind of concept behind Azure Sphere and building applications with Devx. Alrighty, so just popping back to the slides and really just coming back to the end of this talk. So I've covered off and shown you how I built this application, and how I build it with using this library called Azure Sphere Devx. What I would also recommend, and you'll find references to this in the code, is understanding how the Azure Sphere samples work as well, because that Azure Sphere Devx is built on the samples, and it can be useful to understand core context. Now, in terms of some best practices I kind of like to highlight, we have this idea of deferred updates. Now, often for production applications, there are certain times of the day or scenarios where it doesn't make sense to allow an application to update. So for example, you might have an application which is used during the day and you don't want to update the application or allow a system update during the day. You might say, look, I'm happy for the application to update at midnight or 1 in the morning, whatever it might be. So we have this concept of called deferred updates, where an application can request an update. Now you can't update forever. As an application update, I think you can defer up to 7 days. A system update, you can defer up to 1 day. We have also this concept of watchdogs. So you can say, now, your application may fail, it might have a bug in it. And this watchdog, we're saying, is there an issue with my application? And basically what happens is a timer gets deferred, and if a timer gets extended, if the timer doesn't get extended, the operating system realizes, aha, there's a problem with this application. The watchdog has expired, and what will happen is Azure Sphere will restart your application, as well as sending a notification that you can go and look at and understand what's been going on with your application. Exit codes I mentioned before are super useful. You should be using exit codes in there because they provide really a lens into what is happening on that application, and invaluable for debugging to understand what's going on. And things like memory management, you've got to remember that when you're building for embedded devices, you don't have mountains and megabytes of memory. So you do things like static allocation of memory when possible. And there's a great article here on where to go and get more information on memory management. You can find more information on Azure Sphere Devx at that link there. And you'll find there's a wiki and examples there for building applications. And there is also a complete learning path. So if you go up to, in fact, I'll just go search for this. If you go search for MS Learn, find Learn on what we call Microsoft Learn, and we go search for Azure Sphere. And in here, you'll find a whole lot of learning items here on, this was on IoT Central, and you'll find a whole learning path as well. Remember, I provided the full GitHub repo for this particular project. Now, the other thing you might say, look, I'm kind of interested in this Azure Sphere and this Devx, but I don't have an Azure Sphere. I'd like to kind of understand a bit about how this works. So what I also have is this project called Desktop Devx example. And what, if I just bring this up and share my desktop, you'll see that there is a desktop-based application where you can go and basically build the application. So I've ported the Devx libraries across to Linux, because remember, Azure Sphere is a Linux device, so you can run this on WSL, so Windows Subsystem for Linux, or real Linux system. Yep, and you can go and build your application on here. So in this case here, exactly the same I showed you before. Remember, I had bindings. I've got a timer binding. I've got GPIO bindings. I've got device twin bindings. All those types of things. I can go and run this application on my desktop, and of course, it runs much faster. So it's really useful for what I kind of define, looking at how your application is going to interact. It's obviously, it's not got real hardware behind it, but you can go and understand how this works, and it's source code compatible with Azure Sphere and the Devx libraries. So it provides a great way in which you've got a desktop experience, and you can kind of iterate through that process of understanding what the application will look like. You can go and set breakpoints, and you can obviously go and step through that code. This breakpoint hopefully should be hit in a moment. Of course, now I'm looking at it, it's not going to be hit. Oh, it would help if I actually started it up in debug mode. Run that up in debug mode. And you'll see in a moment, it goes and hits the breakpoint. So if you don't have an Azure Sphere, but you're kind of interested and you want to start playing around with ideas, the Azure Sphere, the desktop version of this will kind of give you, it's not really an emulator, but it's got kind of library compatibility. And because it's Linux, it'll pretty much work the same. There are absolutely some caveats, and you do need to look at how that'll the caveats on the web page. Okay, so that is the end of my talk. So hopefully we'll just bring up the slides. So these are resources, and let's have fun and build some amazing solutions out there. Azure Sphere is absolutely about building secure IoT or Internet of Things, or what we decided to call now edge to cloud solutions. IoT Central is a great platform for rapidly building out your solutions. You can really demonstrate the value of your IoT solutions really quickly. And I'll leave up this screenshot here, or screen of resources, so you can understand these are resources, great places to go for Azure Sphere and more resources. Yeah, and finally, do follow me on Twitter. I'm on Twitter at @dglover, and my GitHub is just full of projects for IoT or edge to cloud, and you'll find those up on github.com/globboxes. So thank you very much, and enjoy the rest of the conference. Thank you.
Okay, thank you very much, Dave. I think we will go ahead and take some time for the questions now. We have one question as, do we need to have the entire environment to be on Azure? Is there a possibility to integrate with any other?
Yes. So if that's a question around Azure Sphere, then I've shown Azure Sphere connecting up to Azure resources. And you probably expect me to do that from Microsoft, and our cloud platform is Azure. But you can absolutely connect it up to other platforms. I also have another solution which connects it up to an MQTT broker. So Mosquito, I'm running a Mosquito broker, and I've got a Mosquito broker running in the cloud, and I'm happily sending happily sending telemetry up to that Mosquito broker in the cloud. So in terms of the Azure Sphere itself, though it does use cloud resources, it's not really something that you have to be that mindful of. It's just part of our overall proposition. But in terms of having this device connect you up to other properties, it could be AWS, it could be Google, it could be your own server sitting at home, it could be a server sitting in the office. Absolutely, you can hook that up to different ranges of services. So yes.
Okay, so we have our next question as what are the other suggestive languages that can be used in the development?
Okay, so for Azure Sphere, it is C only, certainly at the moment. So keep that in mind. And that was one of the challenges I looked at when I first started on this environment. I mean, I've got a history of C development, but I appreciate a lot of people don't. Though, interesting enough, C is becoming one of the fastest languages in use today. So if you go and look at various places, so it's a very useful language to look at. So one of my goals behind the Azure Sphere Devx was, if you're not a C developer, then Azure Sphere Devx looks a little bit like a Python solution. I know it's not Python, but the idea behind it is I should be able to read it in a kind of similar way that I can read through Python and say, I understand fundamentally what this line of code's doing. So I'm trying to reduce the noise that you would normally associate with a C application and really make it much more modular. So you can come along and say, I want a timer. I want to go and publish some data to Azure IoT Central. I want to read some data from a sensor, things like that. So it is C, but certainly with that Azure Sphere Devx library, I'm endeavoring to make it much simpler proposition for you if you're not a C developer. So you should be able to do that, but it's C for now. Yeah.
Okay, so learn a new language and enhance your skills in a new technology, right?
And you should know a bit of C. If you're going to do embedded development, I hate to say this, but you should almost always learn C. C is still the language for embedded.
Okay. So it looks like we have covered all our questions, Dave. So is there anything else that you wanted to cover before we wrap up?
No, that's it. And thank you much for everyone for their time. And feel free to reach out to me on Twitter. And as I said, the project is completely documented and up on the GitHub Azure Sphere Gallery. And fundamental thing around Azure Sphere, if someone asks you what's it about, it's about secure by design and secure by default. And it means that Microsoft worries about the security, you just have to focus on your solution. And that's really fundamentally what it's about, because we can't all be security experts. Most of us try and be what we call domain experts. So we have domain experts on healthy workspaces, for example, or domain experts on smart buildings. The challenge we have with IT Central, it can force us to become security experts as well, and that can be a really big challenge. So with Azure Sphere, we kind of help you on that path, manage all security for you, you focus on your application. So yeah.
Okay, so thank you very much, Dave. We are truly honored to have you today with us. And thank you very much for the interesting and informative sessions. As always, we have seen all the webinars on YouTube. Today, we got to experience that live. So thank you very much.
That's absolute pleasure. Thank you much for asking me on board as well.
It's our pleasure. So great. So thank you, everyone. We appreciate you being here.